Hello class, we are back for the second activity of lesson 10. Alright, so working more with partitioned rectangles. You can see these are all examples of rectangles with a partition in them. This is the partition. Okay, so for each rectangle, write expressions for the length and width and two expressions for the total area. Record them in the table and then check your expressions in each row with your group and discuss any disagreements. So this is something that you would have done in class. Let me show you what you should be getting for these here. Okay, so we can switch the width and length around for these, but just for the sake of being consistent here, the width I'm going to use is here. You can definitely call this the height if you'd like, but we'll call this the width for now. All right, so for A, okay, let's go ahead and label each of these right down here. Let's call this A and B and C and D and E and F. Okay, so for A, the width is going to be 3. So we'll go ahead and stretch this out. The width is 3. All right, then the length, well, we can look here and we can see that the length it's A plus 5. A plus 5. Okay, and the area as a product of width times length. So here's how this is going to look. We're going to take the 3, that's the width, and we're going to multiply it by the length, which is A plus, not 6, 5. Okay, and notice I have it in parentheses there because I understand that when I see a number like 3 right next to the parentheses and there's nothing in between them, I know they are multiplying. So this is multiplying, 3 times A plus 5. And then the last expression is going to be like if we work this out, or if we were to break this rectangle down into two parts, it's 3 times A and 3 times 5. So 3 times A, 3 times 5. So 3 times A would just be 3A. We don't know what A is, so we can't give an exact number until we were to find out what A is. So we have 3A, okay, and then we are adding, because of the plus sign here, and then the other rectangle was 3 times 5. Well, that's 15. So this is a look at the general idea for how this is going to work. We are using the distributive property here, all right? So the fact that we have a variable, right, involved doesn't mean that we aren't able to work with it here. We can work out these expressions here, and either one of these expressions can be used to solve the area if we were to ever find out what the actual value of A is. All right, so for B, let's go ahead and work on B. So let's go ahead and stretch this throughout. For B, the width we're going to say is 1/3, this part right here. And then the length is going to be 6 plus x, or if you'd like, you can call it x plus 6. Okay, either way is fine. I like to list the variable first, but if you want to put 6 plus x, that's totally fine. They have the same value. And then for the area as a product of width times length, we're going to take the width, that's 1/3, and we're going to multiply it times the length, which is x plus 6. All right, and then so to come over here and write the area as a sum of the areas of the smaller rectangles, that would be 1/3 times 6 and 1/3 times x. Okay, so here I have it as 1/3 times x first, so I'm just going to write that as 1/3 x. Again, we don't know what x is. We can't actually give it a specific value, so we just put the number and the letter together. This is our coefficient, it's 1/3, and the variable is x. We have a plus sign here, so then we're going to do 1/3 times 6. Now this should be easier than it might seem. 1/3 times 6, 1/3 means we are breaking it down into 3 parts, and we're talking about just one of those parts. So if there are 3 parts out of 6, how much is each part? Well, it has to be 2, right? 2, 2, and 2, that's 6. So we're just talking about one of those parts, so we're talking about 2. 1/3 of 6 is 2. 3/3 of 6 would be 6. All right, so for C, we have a width of r. Okay, we'll keep it consistent r, right? And then for the length, we're talking about 1 plus 1 plus 1. Well, we had to just write it out here because we had a variable involved. We don't know what a plus 5 is because we don't know what a is. Okay, same with this one here, but we know what 1 plus 1 plus 1 is, so I'm going to use 3. If you actually write it out as 1 plus 1 plus 1, that's okay, but because we can easily figure out what that is, we're just going to call it 3. All right, so for the area as a product of width times length, well, we have r times 3, but let me just tell you right now what we want to do is we like to switch this around and we like to call this 3r. Okay, that's the way we like to do it. We like to put the coefficient and then the variable like that, 3r. Even though you could write r times 3 and you'd still be okay. All right, and then for the area as a sum of the smaller rectangles here, well, we just have what this would be here. This would be r times 1, which is 1r, which is really just r. And then 1 times r again, which is just 1r, which is just r again. And then r times 1 is 1r, it's just r. Okay, so you can see here, this is just, these two are, of course, equivalent, right? Each of these expressions, these two, and these two, those are all equivalent expressions. They are the same thing. They mean the same value. All right, for D, let's go ahead and work on that one. All right, we have the width would have to be 6. And the length would be P plus P plus P plus P. All right, if we add all those up, you see here how r plus r plus r was 3r? Well, P plus P plus P plus P, that's 4P. So we're going to call that 4P. And then area as a product of width times length, that's going to be the 6 times 4P. Okay, 6 times 4P, we could also call that 24P, right? Because 6 times 4 is 24, so it'll be 24P. So you could also write that as well. And then for the area as a sum of the areas of the smaller rectangles, well, that would be 6 times P, which would be 6P, and then another 6P. There's going to be 4 of these, right? 6P, 6P. Let me switch that just, there we go. Okay, so the idea is 6 times P, that's 6P, 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 6P. 4 of them, right? If you add all these up, you will get 24 P's, the same way that this is 24P. All right, and for E, we have a width of M, and then the length would be 6 plus 8, right? Well, there's no reason to write 6 plus 8 because we know 6 plus 8 is 14. And then for here, we're going to be taking M, which is the width, and multiplying it times 14. Okay, so we can have it as that way, but remember, as we did before, we like to switch that around. We like to call that 14M. Okay, and then for the last part here, well, this would be M times 6, which would be 6M, plus M times 8, that's 8M. And if you take 6M and 8M, add them together, you are going to get 14Ms. So again, equivalent expressions. All right, one more to go for the activity. We have for F, we have a width of 5, and then the length is going to be 3x plus 8. See that here? We're adding these two, 3x and 8. They are added together. All right, and then so if we were to take this as a product of width times length, again, we're going to follow the same way. This one's just going to start to look a little bit more complicated, but that's okay. It's 5. That's the width. Go to our parentheses, and then we're going to enter in the length, 3x plus 8. Close the parentheses. Okay, so that gets a little bit more involved than maybe we were used to. All right, and so if we were to break this down into the smaller rectangles, or we could multiply these parts here, it's going to be the same thing. It's going to be 5 times 3x, right? 5 times 3x here. So 5 times 3x, that's 15x. Plus 5 times 8, 5 times 8. 5 times 8 is 40. There we have it. All right, don't forget the lesson summary.